most of this brainwasher, so I have not been uploading the videos for a while. So today we're going to talk about Newton. Well, Isaac Newton, he is a British-English mathematician and a scientist, and he discovered pretty cool stuff. Like F equals ma. Or Einstein said it should be which you can also say as this, but we'll talk about it in the next video. I hope someone will put a link on this. So F equals ma. Why is it? Well, we need to talk about someone called Johannes Kepler. Okay, or just John. Kepler said that t squared is kr cubed. Okay, so t is the time it took for one total revolution around the sun, and r is the long one. Since it does not orbit in a perfect circle, so if it was a circle, then you will need a compass to actually draw the radii and all these stuff. But Kepler thought it should not be the circle. It's actually an ellipse. But this is not an ellipse, of course. This is the long one. So this is r. So what Kepler thought is that t must be k r. This is what Kepler thought. So he divided, multiplied, and he squared. He had a root draw all these things. He used logarithms, but it took really simple. Well, nowadays there is a little error on this theorem. But anyway, Newton realized it was a really good idea to use it. First, what he did, I guess the Newton formula, but sorry, I will not talk about this one, but this. Where is the calculator? Okay, so if you put on the calculator and see it, let's see, number 39. It said that G is 6.67428 times 10 to the minus 11th. So yeah, that is G. And this is two objects. So, they are coming close to each other in this force. But this is so small that it'll take like 4.5 in a million years. I guess at the time it was shorter than that, but they would collide. But how can it come? Well, then let's look up in a physics book and let's talk about it. Okay, so it's just like this. You need to think what happens if planetary moves. So when planets move like this, you have a slide force. It's like this. If you spin anything, if you spin it like this marker and you let it go, then it'll go out. Okay? So, and the force is r mv squared. So that is centripetal force. So this is a centripetal force. So in a planetary move, the centripetal force is the force we're talking about. So you can change it to F equals r mv squared. So the velocity of a planet will be v equals the square root of rgm. Oh, sorry. So the time it takes up is v 2 pi r. This is also the planetary move of something. So sorry I didn't tell you about it, but the acceleration and the time in the planetary move can be represented as t over 2 pi v. So that is the reason that it comes to t equals v over 2 pi r. So this equals 2 pi r multiplied by the square root of gm_r. So t squared equals r cubed multiplied by gm 4 pi 2 squared. But here's the important thing. We knew the pi is 3.141592. We know pi is this. And we know g is 6.67 multiplied 10 to the minus 11th. And we know m is the mass of the object. Like in this case, I say 10 kilograms for sure. So this is just a constant. So t squared r squared. And you know what that is? It means that the graph shows a line. Okay, so this is the Kepler and Newton's theorem. So we'll talk about a little more. As the script was a little error, I guess we can talk about Einstein a little more. So Albert Einstein was born in Germany. Okay, Einstein. And he was born in Germany, but he moved on to the US. And he discovered pretty cool stuff in science. Particularly E equals mc squared plus bc squared, according to metaphysics and also according to Einstein. But let's see it. We need to know about a person called Galileo Galilei, which you will know. Yeah. Galileo, he thought light was not infinite. So what he did was pretty cool at the Renaissance. When people thought people were having some kind of piece, like the Mona Lisa and the pest was all around Europe, he thought, it's way years later, but just think. He thought like this. You have a hill, 2 hills, like it's 5 kilometers away. So here is Galileo, and here is his peasant rest, and his mom it should be. So he had a light. Obviously, he had also a light. When Galilei shot a light, he saw it, and he shoot a light again. So, and then this is the first. Then he did the second one. He have the time, and he got C equals almost infinity. So, it was all rubbish. The reason is our eyes cannot have much obvious light with a refractor in it. So that's the reason we are always seeing the past. So, Riemer, I guess the spelling is this, to be precise. He's from Denmark, Danish. What he did is he was looking for Io. You know what Io is. This is the I cannot think about it. Anyway, Io is near to not to scale, Jupiter. So Io will pass by Jupiter, right? Okay. But he said you can see 22 minutes, which is in now times 16 minutes 36 seconds. Hell yeah. So what did you 22 minutes? He got the C equals 2.27 multiplied by 10 to the 8 kilometer per second. That's because the error, because this is C. The error was this. And the fact that Io and Jupiter size, mass, volume, they weren't very precise. So I guess Rimmer did it. It's okay. After Rimmer, all the scientists wanted to know what is C. So Bradley, Fizeau, Foucault, Michelson, and Morley wanted to know what is C. And the person who was real close was Foucault, and Michelson. But Morley did not do any stuff. Instead, he teamed up with Michelson and he said there were no ether. Well, this is sound need to have something to go through. Like sound needs air. So, they said, this was just a conjecture. They said that light needs also mass. They called it ether. But Morley said there were no ether. So, they did was a real complicated experiment. They had a mirror, also a mirror, and this was transparent, half transparent mirror, and you had a light source, and we had a telescope. Okay, so it goes, and then some of the light goes to here, some of the light goes to here. It passes again, and then this light comes to here, the telescope. They said, if there was an ether, since it changes all the way, he said the V will change. But it does not. So they said there were no ether. So Einstein said, well, very good. Michelson Morley experiment, oh yes, and I guess E equals mc squared. Well, not that. We'll talk about in the next video. So, in the next video, we'll talk about the Lorentz transformation, Einstein, and all that stuff. Thank you for watching the video, and please subscribe. I'm gonna no subscriber in the next few months. Anyway, bye.